Thanks for joining me here for another video at Math Rocks with Mr. Cox. This video is going to be focusing on an extension of what you already know about factoring, and that is if you have the difference of two squares, you can factor it into the square root of each one in each of the factors with a plus or a minus in between them. And we also know it doesn't work for a plus instead, so in other words, the sum of two squares. But in this video, we're going to be looking at two cubes. In other words, can you factor two cubes with a minus in between them or two cubes with a plus in between them? So stick around and find out. Let's get it on! Well, the short answer as to whether or not you can factor two cubes is yes, you can factor them. And it doesn't even matter if there's a minus or a plus in between them, both will work. So let's take a look at how that might actually look here. I'm going to use polynomial division to figure out what it would be. And intuitively, you might think, well, if we take the cube root of this, it's x, and it is. And the cube root of negative 125 is minus 5. So let's do our division of that and let's see what happens here. So I'm going to go ahead and drag down the x to the third down into this first box. X times x squared gives me this. X squared times negative 5 is negative 5x squared. I need to have no x squareds because I don't have any here, so I'm going to have a plus 5x squared right here. So together we're going to have 0x squared, which will work. X times 5x will give me this. 5x times negative 5 is negative 25x. To get no x's, because we have no x's up here, I'm going to have a positive 25x right here. And x times positive 25 will give me that. And 25 times negative 5 is negative 125, which is a match with the other number here. So that means x to the third minus 125 will factor into the quantity x minus 5, and then times the quantity x squared plus 5x plus 25. So now let's see how it would work if we had a plus in between. Once again, intuitively, let's go ahead and take the cube root of 8x to the third. That would be 2x. And the cube root of 27 would be a positive 3. I'm going to drag down the 8x to the third here. Then I have to say, well, 2x times what gives me this? Well, that would be 4x squared. 4x squared times 3 would give me 12x squared. I don't have any x squareds up here, so I'm going to have a negative 12x squared to balance that out. 2 times negative 6x will give me the negative 12x squared, and then negative 6x times 3 is negative 18x. I have no x's up here, so therefore I need a positive 18x to balance out the negative 18x. 2x times 9 would give me that, and 9 times 3 is 27. So even when there's a plus, unlike the difference of two squares, with cubes it will actually work. And our answer would be the quantity 2x plus 3, and then times the quantity 4x squared minus 6x plus 9. All right, so here's the answers we just came up with in the previous part of the video. And it turns out there's actually a pattern that always holds true. And if you notice over here, if we were to take x and square, that's the first term in the trinomial. If we take 5 times x, that gives us the 5x here. And the only difference is rather than having a minus, we have a plus. And if we take 5 squared, we get the 25. It also holds true over here too. If we square 2x, we get 4x squared. If we multiply these two together, we get 6x, and it's a minus instead of a plus. And then 3 times 3 is 9. And so this is the general rule right here for how you factor cubes. And it's almost identical. The only difference is if we have a minus in between the cubes, we're going to have a minus in the binomial, and we're going to have a plus with the second term of the trinomial, and then the reverse is true here. If we have a plus between our cubes, we're going to have a plus between our terms in the binomial and a minus before the second term in the trinomial. And really all it works is this. You just ask yourself, well, what would be the cube root of, in this case, of 27x to the third? Well, that would be 3x. And the cube root of 64 is 4. And because we see a plus here, put a plus here in between them. Then what we do is we square the 3x. We would get 9x squared. Because that's a plus, we're going to say minus. 4 times 3x is 12x. And then finally, we put a plus, and 4 times 4 is 16. So that's how you factor it really quickly. You don't need to do division every time once you realize what the pattern is. As always, if you like what you see, please like, comment, or subscribe. Thank you, and now back to part 2. And finally, what we're going to look at is how to solve two cubes. And so we're going to be looking at the function f of x equals x to the third minus 8. We're going to be finding the roots, and we're also going to describe the roots as well. So in order to find the roots, what we're going to do is we're going to set x to the third minus 8 equal to 0. And we already know to factor this, we're going to have to take the cube root of each. So that'll be x, and we're going to throw in a minus and then a 2. And then the reason why it's a minus, once again, is there's a minus there. And then what we do is we square the first term, which is x, so x squared. Multiply them together, 2 times x is 2x, but put a plus. And then square the last term right here, so 2 times 2 would be 4. All right, once again, I said this earlier, but I'll say it again. This part right in here, the trinomial, is not going to be factorable, so we're going to need to use the quadratic formula. This one is really easy. If we set x minus 2 equal to 0 to find the root, we would get x equals 2. And by the way, obviously that is a real and a rational root. So when you're asked to describe them, that's all that means, is it real or complex? And if it's real, is it rational or irrational? Let's go ahead and work with the one over here. So I'm going to go ahead and there's an invisible 1 out here. So with the quadratic formula, a is 1, b is 2, and c is 4. So now when we go ahead and we actually do the quadratic formula, we're going to go x equals, the opposite of b is negative 2, plus or minus. I'm going to square b, so 2 squared is 4, minus 4 times 1, which is what a is, times c, which is 4. And then it's going to be all over twice a, so twice 1 is 2. So now when you go ahead and take 4 minus 4 times 1 times 4, you are going to get negative 2 plus or minus the square root of negative 12 inside the square root, all over 2. So we're going to this is going to be an imaginary number right here, and together this is a complex number altogether. But what we can do is we can write 12 as 4 times 3. So now what we can do is we can actually pull out the negative and the 4 by square rooting the 4, and we wind up with negative 2 plus or minus 2i square root 3 all over 2. And then for our final move here is we can go ahead and divide all of these by 2. So I'm going to wind up with a negative 1. Then I'm going to plus or minus. I'm going to have 1i, so I'm just going to write I square root 3 all over 1, which is just basically negative 1 plus or minus I root 3. And these are what we call two complex roots. So that's how it works. The factoring is pretty straightforward, but then you're going to have to use the quadratic formula to find the rest, and you're going to wind up all the time with one real root that's rational, and you're going to wind up with two complex roots. Hope you got a lot out of this video, and hope to see you again soon. Thank you.